Energy Switch is the popular point-counterpoint show where two leading experts with different perspectives discuss the most pressing energy and climate issues in the news today. Next on Energy Switch, water requires energy and energy requires water. We'll talk about how they intersect.
Funding for Energy Switch was provided in part by the University of Texas at Austin and by EarthX.
To produce, purify, transport, and recycle water for municipal use, for electricity generation, and for agriculture takes massive amounts of energy. And to cool power plants, produce oil and gas, and mine fuel and materials requires an enormous amount of water. We'll look at the intersection of energy and water and how we could use less of one to make more of the other, with my expert guests, Dr. Afreen Siddiqi from the Science, Technology, and Public Policy program at the Harvard Kennedy School. She's also a research scientist at MIT, focusing on technology, policy, and international development.
The electric power sector in this country is the largest user of water, ahead of agriculture. But that's changing. From 1950 and onwards, there has been a constant drop of water use per unit of electricity generated.
Joining her is Dr. Newsha Ajami, a Chief Strategic Officer for Research at the Lawrence Berkeley National Lab and Director of Urban Water Policy at Stanford University, focusing on sustainable water resource management.
One thing I think it's important to mention, quality degradation is actually quite real. Power sector might not actually have a lot of consumptive use, but it certainly participates significantly in degrading water quality.
I'm Scott Tinker, and I'm an energy scientist. On this episode of Energy Switch, we'll look at the critical energy-water nexus. So let's talk about how energy really allows us to provide water. Start right in with municipal water systems.
Well, we use energy in municipal water systems every step of the way. We use energy to pump water from original sources, which might be from a river or a lake. Then we use energy to pump it across sometimes long distances to bring it to a water treatment plant. Then we consume energy to treat that water within that treatment plant to make it fit for drinking and for human use. Then we use more energy to distribute it to our homes and buildings within a city. And then once the water is in our homes, we use energy to actually use it. And then once we're done, we actually use energy to sort of collect it and take it to sewage plants, treat it again, and make it so that we can safely dispose it into the environment. So every step of the water segment or the water chain, so to speak, we're consuming energy.
Is a lot of the energy itself that's used electricity for most of these things?
In most cases, yes, absolutely. In some cases, there is use of diesel, particularly when we start talking about agricultural applications.
Sure.
You'll see some countries are using that.
How do we use water in households, and how do we use energy to do that in households?
Sure. Yeah. In our house, we use water for a lot of different things that we do, right? Think about dishwashers, washing machines, water that comes out of your taps, flushing toilets, showering. Depending on what we're using water for and if it's need to be heated or not, they have different kind of energy footprint. For example, if you need to use the hot water to run your dishwasher or washing machine, obviously a lot of people use natural gas. However, everything else is using electricity just in order to move water around. And actually what we saw in about like 30 years ago when we started sort of paying attention to energy efficiency, the first thing we started doing was trying to make appliances more water efficient in order to use less energy.
Yeah, energy is such a precious resource, so is water. That's a win-win.
That was definitely a win-win.
Right.
Absolutely, absolutely.
And if I can add to that, I mean, if you look at household use of energy by category, after space heating, the biggest category is water heating, which constitutes anywhere from 19 to 32% of the energy use within a home.
Right.
And it's a significant amount of energy.
You know, when we built this modern water system that we have right now, I call it the 20th century water model. We use a lot of energy and resources to clean up water. Whatever water that comes out of your tap is a drinkable quality water, right? And we use a lot of that water for purposes that does not require drinkable water quality, right? You water your outdoor spaces with drinkable water quality, you flush it down your toilet. And that is a very inefficient way of doing things. The same thing goes with leaks and aging infrastructure that lose water along the way. You're using a lot of energy and resources to bring that water to high quality, and then you lose it along the way. So I think the system that we have built, it's quite inefficient in many different ways, not just because we are bringing water from long distances, but the way we distribute water in the homes also quite inefficient.
That's interesting, Newsha. I mean, I hadn't really even thought about that.
Yep.
So we could have a drinkable water connection, and then maybe a little grayer water for other uses that wouldn't matter at all.
Absolutely.
So treating wastewater before it goes into the environment is very energy intensive.
Yep.
What happens there from my house to somewhere?
If you see globally, you'd be lucky to be in a city where the water, once we've used it, gets safely collected and then safely disposed. Unfortunately, in many countries and many cities around the world, actually that doesn't happen. So simply the wastewater literally, will get dumped into rivers, it'll be dumped into the ocean and so forth. So there's no treatment whatsoever, which creates environmental issues, public health issues.
How common is that? Is it half the people in the world? Or?
Most developing countries will have very little infrastructure. I know the last time I checked for, in a report in the mid-2000s for Pakistan, there were just a handful of wastewater treatment plants. And this is a country of today over 200 million people. So that's one part of the story. If you are in a city where water is, let's say, much more handled carefully, then that wastewater treatment plant will put it through various stages of processing. Average consumption of energy for wastewater treatment is lower than, let's say, things such as desalination, or if we're talking about, groundwater pumping from deep wells, that can be much more expensive.
Yeah.
And that's why the argument for recycling and reusing it becomes stronger from an energy perspective.
From an energy penalty.
Yeah.
Talk about desal a little bit. Who's doing that and what is it?
Yeah, so desal, you basically push water through a membrane, semi-permeable membrane, to separate water molecules from every impurity that's in the water. And it can be used for different purposes. Often when we say desal, everybody thinks about seawater desalination. But again, we use the desalination process for treating brackish water, which is like deep groundwater that is salty, or actually can be used for the reuse process. The same technology can be used to take the wastewater and get drinkable water out of it.
Okay.
But for smaller countries, such as some of the countries in the Persian Gulf, for example, or Australia, that have a smaller population, you might be able to generate a bigger portion of your water supply from desalination.
How about feeding everybody on the planet? We have 8 billion now. We're growing. A lot of dense agriculture, a lot of water needs. How's energy used for irrigation and things like that?
Well, again, it depends. The irrigation that happens in regions where they're using pumped water and they're taking it either from the ground or from long-distance pipelines can get pretty energy intensive. In India, in Mexico, in Pakistan, in China, other countries that have large populations, big rural agricultural economies, the energy used for irrigation for agriculture can actually be pretty significant, ranging from, 10, 20, 30, 40% of the energy used in that particular part.
That's big numbers.
And one other part of agriculture that I think requires a lot of attention is the waste side of it. So not everything that we produce is consumed. Some of it is wasted at the farm, and some of it is wasted in locations that they get delivered to, and some of it actually becomes a food waste. So trying to harness
You're talking about the water is wasted.
Water and energy.
And therefore the energy.
Therefore the energy.
How do we lower the energy intensity of those things?
Let's talk about actually water use as a general term, right? We use a lot of water in our homes for different purposes. I mean, US is about 60 gallons per person per day, but in California it's about 100 gallons per person per day. That's a lot of water we use, and that's a lot of energy. And trying to reduce that can actually significantly impact both our water footprint and energy footprint at the same time.
100 gallons per person per day.
Yes.
That's not just the water in my home, though. That's accounting for all the water I use as a person in agriculture and everything?
No,
or is
no,
that
no.
just...
No. This is actually the water that you use in your home. 60 gallon per person per day.
So my 40-gallon hot water tank.
Yes,
Or
and also
60-gallon
showers that you take.
Each of us uses that whole thing.
Yes.
Every day.
Yes.
Wonderful.
And also remember, this is average, so it means that there are people who use 200 gallons per person per day, and there are homes that they use. For example, in San Francisco, we use about 40 gallons per person per day. So it's denser city, much less outdoor water use, and we use a lot less water versus like when you have sprawling suburbs that you have to move water from far distances, bring it here, and then push it through the system to make it to the all the way to wherever you need to deliver the water, and then collect that wastewater and bring it back.
I think it really requires top-down as well as bottom-up approaches. So top-down, I would say that even when we're thinking about new urban developments, right? How can we design our cities or develop new areas so that we're very consciously making decisions about layout and the overall architecture so that it is better in terms of energy use, water use. Can make a big difference because a lot of things have grown organically, and therefore the decisions that were made were sort of made, over time. And now if we could start with the clean sheet design, so to speak, for a new development, we might do things very differently.
Hopefully we're smarter now.
Actually, we have done specific research on this, and we have found actually the new development is much more efficient, water-wise, energy-wise, compared to old development. And the saddest part of this whole situation is we are still building cities, communities, the same way we did 50 years ago. And I think water sector is certainly behind energy sector in all this. And we can do a lot better with smart metering, with having better information technology to take this information and turn it into knowledge that can be communicated to people, then they can make more conscious decisions.
We talked about energy providing water. Water helps provide our energy. Let's talk about that. How much do we use for cooling thermal power plants? Natural gas, coal, nuclear. How much is used in these cooling, and is it destructive?
It turns out that actually the electric power sector in this country is the largest user of water. Ahead of agriculture. So if you look at data from, USGS, it's 41% of water withdrawals, total water withdrawals overall, were by the electric power sector.
To cool it.
For cooling purposes. Now, there is a catch, though. Water can be withdrawn from a source, run through these power plants for cooling, and then it is put back into the same source from which it was taken, although at an elevated temperature. But that's changing. From 1950 and onwards, there has been a constant drop of water use per unit of electricity generated. It was about 75 gallons per kilowatt hour. And by 2017, it stood at 13 gallons per kilowatt hour. So there has been a tremendous decline in so-called water intensity for electric power production in the country.
That's good news, That's
I mean, one thing I think it's important to mention is the quality degradation is actually quite real. For example, heat can cause ecosystem loss or impact freshwater ecosystems. So power sector might not actually have a lot of consumptive use, but it certainly participates significantly in degrading water quality.
Because you're putting hot water out into an ecosystem.
Yes, and the temperature
cool off.
Exactly, and the ecosystem that depends on that water, they basically expect a certain temperature. So increase in temperature can be quite significant. Another piece of it is actually, for example, in California now, we have started transitioning from using water, any kind of water, for cooling. So we are actually now doing dry cooling. So dry cooling, or they call it dry cooling or air cooling.
Is that more energy intensive?
That is more energy intensive, but it's much less water intensive. But if you are in the Western U.S. and you don't have a lot of water supplies, you should not be using that. You have to make that choice. We also have to remember power is not just only electricity, it's also oil and gas production, biofuel. There are so many other parts of this, right? And actually the consumptive use of water in those industries are quite higher than electric generation.
Let's get to those. Let's talk about hydroelectric. How much is lost there? Just big dams.
So a lot of that is true evaporation, but we have to remember dams are built for multiple purposes. It's not just hydroelectric. A lot of them do actually provide water supplies and also do flood protection. Dams potentially can have multiple benefits. So one thing I would say on the hydropower side is they are being impacted by the change in climate patterns that we are experiencing and reduction in snowpack and the flows and all that. So for example, Oroville Dam in California, it actually for the first time last year had to shut down its electrical production because of low water levels.
Droughts.
Yeah, because of the drought. And this dam has been around since 1968 and that has never happened, right?
So depending on your time frame, it's not renewable.
It's not. And actually,
I mean, it's no emissions, but you got to have water.
I mean, there are emissions. The water in the reservoir can generate a significant amount of methane because of the, plant degradation and everything that happens in the water. So they definitely do emit greenhouse gases. But, again, nothing is perfect. Everything that we do has some form of a negative impact. So we have to actually be better and smarter about how we do things. And hydropower is one of them.
Let's talk about oil and gas, which is, depending on where you are, 50, 60% of our energy still.
Yeah, I mean, the amount of water that gets used also depends on how you're extracting it, right? So, if you look at sort of the traditional ways in which oil wells were operating, there was water use, but not to the level to which now we're seeing when it comes to hydraulic fracturing. From the numbers that I've seen, it can be anywhere from 1.5 to 16, million gallons of water being used for a single well. And you can sort of even see from this range, there's a whole order of magnitude difference. So it really varies on, what type of operations and what the well is and so forth that we're talking about. But it is a big user now.
Now you produce water, flowback water and formation water. Is some of that able to be used again in productive ways? Or?
I mean, we are not using it as much right now, but there is potential to use some of these desalination technologies, for example, to clean up that water and use it for agriculture. Now the question becomes how to make it affordable for an agricultural production to use it and be able to deliver the same cost crops or the same cost of products to the market.
Let's talk about mining and water.
Yeah, well, so certainly water is used for mining. Majority water is brackish water that gets used in this country. So if we're talking about use of fresh water to mine coal, that, at least from the literature that I've seen, is not a major sort of issue. That said, there are other things that are on the horizon. There's a lot of discussion and awareness being generated about the water impacts for lithium mining, right? So since we're talking about renewables, mining for these kinds of metals, which historically has been at a lower level, what would that imply for water? Lithium mining can be very intrusive and very important when it comes to the water connection.
I mean, we have tens of billions of batteries in the world today for our gadgets, but we're going to go to trillions when we start putting them in cars.
Absolutely. And right now, a lot of us, when we think about, renewable energy, we are all super excited, but we are not thinking about this as what kind of environmental footprint are we, having in creating this bright future. I think we should remember we have Clean Water Act that protects a lot of activities that can cause harm to the environment or our water systems. However, this means that some of these activities have been shifted to other countries that have weaker environmental regulations. And then those communities are stripped off their water supply sources. But, they're happy for a while because they're making money. But at the end, in the long run, these things are not sustainable, right?
So we've talked about thermal power plants and hydroelectric systems, oil and gas, mining. Again, water required
for every one of them.
For energy.
Yes.
Pick your favorite technology or two that might help in any one of those things. How do we use less water in our energy production?
The ones that I'm very excited about, digitalizing the system and creating more awareness in the process as we are doing that. Tracking what is happening. Because when you measure, then you can manage. If you're not measuring, you can't manage it.
So if you look at, the the use of water for electricity generation that we were just discussing, it has gone down partly because of a technological transition in how we are generating electricity. And we've retired a lot of nuclear plants. We retired a lot of coal plants. Those were the ones that were actually withdrawing the largest amount of water. Now we're basically ending up with newer plants that have actually better technologies for cooling, especially combined cycle gas and so forth.
Sure.
So the question is, can we continue? And that's where the renewables come in. So when we talk about solar, when we talk about wind, one of the advantages is that they don't rely on water.
Let's talk about spills a little bit. I'm not sure we've talked much about that. Oil-related things, coal ash, mining. What are some of the impacts you've seen there with that?
Yeah, so that's a big issue, and you know, the U.S. EPA estimates that there are about 1 million gallons of oil that are spilled into the oceans. There were some very famous ones that happened in history, which created a lot of press, but there are smaller ones that happen during you know, oil and gas extraction. And they can pollute, you know, sort of the local waterways. And then coming back to, you know, the question on coal ash, that's one of the biggest categories of waste produced from U.S. industry. So it's significant. About over 100 million tons of coal ash gets generated. And if that gets into the waterways, which it has, it can really seriously damage the water resources.
Sometimes we also have municipal waste that gets overflown and ends up in our water bodies. I think one thing that's important to remember is that every time we degrade water, if we want to use it, we have to use electricity and energy and power to clean it, right? So preventing pollution can actually help us save a lot of resources when it comes to that.
If you could write the future, policies, financing, technologies, you know, what advances would you like to see made?
I mean, I would build cities in a different way. I think we have an opportunity to rethink and reimagine our cities and communities. And I think when it comes to water, I would start from the smallest unit, which is a home, and try to sort of create a circular water water system around it. So trying to recycle and reuse water as many times as we can in our homes, and then try to do it at the building scale, and then try to do it at the city scale. These are opportunities that we have today, and we can create future cities today. We are actually building future cities today. Whatever we build today is going to last another 50, 60, 100 years. And I think stepping outside of our U.S., I think in developing world, we actually have a brighter opportunity, easier way of rethinking and reimagining how we build future communities. According to the United Nations, about 70% of the population is going to live in the urban areas by 2050. 60% of those have not yet been built. So we have an opportunity to build those very differently from the way we did it today.
And considering this energy-water nexus that we've talked about, energy needed for water, water needed for energy. What about everything that exists today, though? I mean, can we improve that, too, as you think about your future?
You know, everything that exists today certainly is subject to a lot of new risks. In some cases, there are, you know, retrofits that are available that may not be as costly, can create a lot of energy savings. In fact, if you look at, you know, the cost of energy, the payback period might not be that long. So it may make a ton of sense, actually, to go ahead and do that. But I feel a fundamental need for valuing and accounting for water. And I think that can make a pretty big difference in how we make decisions, in how corporations make calculations, how households make and make their choices, how governments perhaps may pursue policies, really accounting and valuing water. So if we have a sense of, you know, how our water resources are increasing or decreasing over time, our so-called inclusive wealth changing over time, we can be just better informed and better prepared to make policy decisions.
Really, really thoughtful dialogue and conversation.
Yeah, thanks for having us. That was great.
And
Thank
appreciate
you.
all you
Thank
shared
you so
with
much.
us. Energy is consumed in every step of water production and use. Some of that is diesel, but mostly it's electricity. That means that places that don't have abundant, reliable electricity also don't have modern water services. Not only no purified drinking water, wastewater often can't be treated and is released into the environment. In places with abundant energy, salt water can be desalinated for human use. irrigation for agriculture can be very energy intensive. Cooling electric power plants uses slightly more water. There's very little evaporative loss, but some environmental degradation due to heat. Water is also used in hydropower, of course, and to produce oil and gas, particularly through hydraulic fracturing. Mining for energy minerals uses water, but overall, solar and wind use less water than other energies. In the future, we can better design new urban development to better manage our water use.
Energy Switch is executive produced by Scott Tinker and produced and directed by Harry Lynch. Sophie Byard is the assistant producer and researcher. Editors are Ginny Patrick, Yusef Swachina, and Jackie Kunzler. Matt Aslanian does the sound. Energy Switch is produced by Arcos Films for the Switch Energy Alliance, with support from the University of Texas at Austin and EarthX.